Here is an example problem. The city distributor of air conditioners in Manila has divided the area into 4 sub-areas. The prospective buyer of the distributorship was told that the installation of the equipment are equally distributed. The prospective buyer took a random sample of 30 installations performed during the past years from the corporation's file and found the following. So here are the units installed in sub-areas. In A we have 6, and B we have 12, C we have 14, and in D we have 8. So we have the total of 40 units installed. So the question is, based on the information, can we say that units are equally distributed using the 0.05 level of significance? So the first thing to do is to find the null hypothesis and the alternative hypothesis. This problem, a prospective buyer of distributorship was told that the installation of the equipment are equally distributed. He took a random sample of 40 installations performed during the past years. If these samples on past years is equally distributed, here are the samples. Our null hypothesis will be that the observed frequency will be equal to the expected frequency. It is this that the installations of equipment are equally distributed. And our alternative hypothesis is that this observed frequency here and the expected frequency are not equal. The null hypothesis, where the observed frequency is equal to the expected frequency, where the alternative hypothesis is the observed frequency is not equal to the expected frequency. The next thing to do is to find the expected frequency. This is the formula where expected frequency is equal to the summation of the observed frequency over n. We can see here that the summation of the observed frequency is 40. And our n will be the number of sub-areas. 1, 2, 3, 4. 40, the summation of the observed frequency is 40, and our n is 4. Dividing 40 by 4 will be equal to 10. Our expected frequency is 10. We can see here in the problem that the equipment are equally distributed. So it means that the expected frequencies have an equal expected frequency. Expected frequency will be equal to the first expected frequency, the second, the third, and the fourth sub-areas. We have here the level of significance. We get it here in the problem where we have to use 0.05 level of significance. Next thing to do is to find the degree of freedom. With df, that will be equal to the number of categories minus 1. So we can see here that our number of categories is 4. So we have here 4 minus 1, that will be equal to 3. So we have the df of 3. We have our level of significance that will be equal to 0.05 and the df of 3. Finding that on the x-squared tabular, finding that in this table where df is 3. This is our df, and we have the level of significance 0.05. So we have here this one and this one. So we have here 7.815. X squared tabular will be equal to 7.815. The next thing to do is to compute the value of chi-square statistics. In this table, first put our observed frequency and our expected frequency. You can see here that our observed frequencies are 6, 12, 14, and 8, and our expected frequency equal to 10, where our expected frequency in first sub-area, second, third, and fourth are equal. In finding x squared, we have a formula where the summation of the observed frequency minus expected frequency squared all over the expected frequency. In computing, let's have this one where our observed frequency is 6 and our expected frequency is 10. This is 6. Computing the formula with the formula OI minus EI, we have our OI 6 minus 10 squared all over EI over 10. 6 minus 10, that will be 4. And 4 times 4, 16 over 10 will be 1.6. You can see here that it is 1.6. And try to solve this on your calculators. The observed frequency of 12 and the expected frequency of 10 will be 0.4, and so on. Finding the summation of this, we get 4.0. Try it on your calculator and you'll get 4.0. Our x squared computed and x squared tabular. Our x squared computed will be 4.0. 4.0. And our x squared tabular, here, it's 7.815. 7.815. 7.815. We can now decide our x squared tabular is greater than the x squared computed, where this is our decision, where we accept the null hypothesis and reject the alternative hypothesis because the computed value is less than the tabular value. If you find that the computed value is greater than the tabular value, it means that we have to reject the null hypothesis and accept the alternative hypothesis. You can see here that the tabular value is greater than the computed value, so we have to accept the null hypothesis and reject the alternative hypothesis. Conclusion: we can see here that null hypothesis is that the observed frequency is equal to the expected frequency. Since the expected and observed frequency are confirmed to be equal, therefore we can say that the installments of the equipment are equally distributed in 4 sub-areas.
If you learned something from this video, please hit that like and subscribe button above for more videos. Thanks for watching.